Reach into your pocket. If you're old enough, or if you collect coins, you may have one. A Jefferson nickel dated 1942, 1943, 1944, or 1945. It looks like any other nickel. Same size, same weight, same portrait of Thomas Jefferson on the front, same image of Monticello on the back. But turn it over. Above the dome of Monticello, where no letter normally appears, you'll see a large mint mark, a P, a D, or an S, bigger than any mint mark on any American coin before or since. That oversized letter is a flag. It marks the coin as different, because that nickel in your hand contains no nickel at all. It is made of 56% copper, 35% silver, and 9% manganese. The United States Mint removed every atom of nickel from the 5-cent coin in the fall of 1942 and did not put it back until the war was over. The large mint mark, the first time the letter P for Philadelphia had ever appeared on an American coin, was stamped there so that after the war, the silver coins could be easily identified, pulled from circulation, and melted down. This was not a symbolic gesture. This was metallurgical triage. The United States government determined that the nickel in a 5-cent coin was more valuable inside the armor plate of a Sherman tank, the exhaust valves of a B-29 Superfortress, and the turbine blades of a destroyer than it was in the pockets of American citizens. So they took it out of the coins and sent it to the furnaces. The story of what made nickel so critical that the nation's currency had to be redesigned in the middle of a war, begins not in Washington, but in a crater in the Canadian wilderness. 1.8 billion years ago, a meteorite, roughly 10 to 15 kilometers in diameter, struck what is now northern Ontario, Canada. The impact created a crater 60 kilometers long and 30 kilometers wide, the Sudbury Basin, one of the largest impact structures on Earth. The violence of the collision melted rock to extraordinary depths, and as the magma cooled over millions of years, dense metallic minerals, nickel, copper, platinum, palladium, settled and concentrated along the basin's rim. The deposits were discovered in 1883 during the construction of the Canadian Pacific Railway. Workers blasting through rock near the small camp of Sudbury noticed copper mineralization. Within 3 years, the Canadian Copper Company had been formed by Ohio businessman Samuel Ritchie to extract the copper. Then, an unpleasant surprise. The ore contained enormous quantities of an unfamiliar metal that contaminated the copper and complicated refining. The metal was nickel. At the time, there was virtually no commercial demand for nickel, and the standard refining process could not easily separate it from the copper. The entire enterprise nearly collapsed before it began. Then, in 1980, the United States Navy conducted tests in Washington that changed everything. Armor plate made from a nickel-steel alloy, iron alloyed with a small percentage of nickel, proved dramatically harder and more resistant to penetration than ordinary steel. The result was, in the words of one historian, a metallurgical equivalent to the atomic bomb. Every navy in the world suddenly needed nickel for its warships. The dreadnought battleship, the supreme weapon of the early 20th century, required nickel-steel armor plate measured in thousands of tons per vessel. Sudbury had the nickel. By 1902, 2 companies dominated the basin: the Canadian Copper Company and the Mond Nickel Company, founded by the British chemist Ludwig Mond. In 1916, these entities consolidated into the International Nickel Company of Canada, Inco, which would become the most important strategic metal producer in the Western world. By 1939, Inco supplied approximately 90% of the non-communist world's nickel. Sudbury was not merely a mining town. It was, in strategic terms, one of the most important patches of ground on the planet. A Maclean's journalist named James H. Gray would later write, "Given the chance, Hitler would willingly have traded the whole Silesian basin and thrown in Hermann Goering and Dr. Goebbels to boot for a year's possession of the Sudbury Basin." He was not exaggerating. Nickel is element 28. It is a silvery white metal, hard and ductile, with a melting point of 1,455 degrees Celsius. Its most valuable property is not its own strength, but the strength it gives to other metals. The discovery that changed everything occurred in 1890. The United States Navy, seeking stronger armor for its new generation of steel warships, conducted a series of tests in Washington, comparing plain carbon steel plate with steel alloyed with small percentages of nickel. The results were decisive. Nickel steel armor was dramatically harder, more resistant to penetration, and more capable of absorbing impact energy without shattering. A shell that punched through plain carbon steel was stopped by nickel steel of the same thickness. A shell that cracked carbon steel armor, spraying lethal fragments into the ship's interior, deformed nickel steel armor without fracturing it. The physics is straightforward. Nickel dissolves into iron at the atomic level, forming a solid solution that disrupts the regular crystalline structure of the iron. This disruption makes it harder for the metal's crystal planes to slide past each other under stress, the mechanism by which metals deform and fail. The result is steel that is simultaneously harder and tougher. Harder, meaning more resistant to penetration, tougher, meaning more resistant to cracking. This combination is rare. Most metallurgical treatments that increase hardness also increase brittleness. Nickel achieves both without the trade-off. Nickel also stabilizes what metallurgists call the austenitic phase of steel, a particular crystalline arrangement that exists at high temperatures and is normally unstable at room temperature. In nickel-rich steels, especially the stainless steels that also contain chromium, the austenitic phase persists at all temperatures. This gives the metal its characteristic combination of corrosion resistance, formability, and strength. The 18-8 stainless steel, 18% chromium, 8% nickel, is the most widely used alloy of this type, found in everything from surgical instruments to chemical processing equipment. Without nickel, the chromium alone produces a different, more brittle crystal structure. The two elements together create something neither achieves alone. Beyond alloying with iron, nickel forms the basis of a family of superalloys, metals engineered to perform at extreme temperatures. Monal, invented at Inco's Huntington Works, is a nickel-copper alloy with roughly 67% nickel and 30% copper. It resists corrosion by salt water, acids, and alkaline solutions, and maintains its strength at temperatures up to 500 degrees Celsius. Inconel, another Inco invention, is a nickel-chromium alloy that can operate at over 1,000 degrees, the temperature inside a jet engine or a supercharger turbine housing. These alloys existed because Inco had both the raw material and the research capacity to develop them. The Huntington Works was simultaneously a factory and a laboratory, and the alloys invented there went directly into the weapons that consumed them. These properties made nickel indispensable to every category of weapon in the Second World War. Armor plate. The armor on a Sherman tank, on a destroyer, on an aircraft carrier, contained nickel as a critical alloying element. Nickel made the armor hard enough to resist penetration, but tough enough to absorb energy without cracking. Without nickel, armor plate was brittle. It might stop a shell, but shatter in the process, spraying deadly fragments inside the vehicle it was supposed to protect. Aircraft engines. The Pratt & Whitney R2800 Double Wasp, the Wright R3350 Duplex Cyclone that powered the B-29 Superfortress, and every other high-performance radial engine used nickel alloys in their exhaust valves, valve seats, and supercharger turbine blades. These components operated at temperatures exceeding 700 degrees Celsius under enormous mechanical stress in an environment of corrosive exhaust gases. Nickel alloys, Inconel, Monel, and other specialty metals developed by Inco were the only materials that could survive. Naval vessels. The Pacific War was fundamentally an amphibious war. Every landing craft, every destroyer, every submarine operated in salt water, one of the most corrosive environments on Earth. Nickel alloys in engine components, propeller shafts, heat exchangers, and condensers resisted saltwater corrosion where ordinary steel would fail within months. Ordnance. Gun barrels, recoil mechanisms, breech blocks, and ammunition All used nickel-steel alloys for their combination of hardness and toughness. A gun barrel that must contain the explosive force of thousands of rounds without cracking requires steel that is simultaneously very hard and very resilient. Nickel provides both. Portable bridges. The Bailey Bridge, the prefabricated modular bridge that Allied engineers threw across every river in Europe, used nickel-steel structural members that were lightweight enough to be carried by soldiers and strong enough to support a tank. The B-29 Superfortress, the most complex and expensive weapon of the war, used thousands of pounds of nickel alloys in its 4 Wright R-3350 engines alone. Each engine had 18 cylinders. Each cylinder had exhaust valves made of nickel alloy. The turbocharger turbine blades, spinning at tens of thousands of RPM in exhaust gas temperatures exceeding 800 degrees, were nickel alloy. The fire control system, the pressurized cabin structure, the landing gear, nickel throughout. This is why nickel was one of the first metals to require government allocation when the war began. Non-essential civilian uses were banned immediately, and the 5-cent coin, which had contained 25% nickel since 1866, was identified as a source of strategic metal that could be recovered without mining a single ton of ore. The Jefferson nickel, introduced in 1938 to replace the Buffalo nickel, was composed of 75% copper and 25% nickel, the standard American 5-cent alloy. It was a small coin. Each one contained approximately 1.25 grams of nickel. Individually, this was trivial, but the United States Mint struck hundreds of millions of nickels. In aggregate, the nickel locked up in American coinage represented a meaningful quantity of a strategic metal that the war machine desperately needed. In the spring of 1942, the War Production Board and the Treasury Department agreed nickel must be removed from the 5-cent coin. But the replacement alloy had to satisfy a peculiar set of constraints. It had to work in vending machines. Millions of American vending machines for cigarettes, candy, soft drinks, subway tokens were calibrated to accept the specific weight, diameter, and electromagnetic properties of the standard nickel. A replacement coin that jammed every vending machine in the country would be an economic disaster. The Mint tested numerous alloys. The solution was unexpected: 56% copper, 35% silver, and 9% manganese. Silver was less strategically critical than nickel. The United States had enormous silver reserves, including the contents of the Treasury's own vaults. The 9% manganese was precisely calculated to match the electromagnetic signature of the original copper-nickel alloy, ensuring that the new coins would be accepted by existing vending equipment without modification. The first war nickels were struck at the Philadelphia Mint in October 1942. To distinguish them from regular nickels, so they could be sorted out and recovered after the war, the Mint placed an oversized mint mark above Monticello on the reverse. Philadelphia coins received a large P, the first time in American history that the Philadelphia Mint had used a mint mark on a circulating coin. This was a remarkable break with tradition. Since the founding of the United States Mint in 1792, the Philadelphia facility had never placed a mint mark on its coins. The absence of a letter was itself the identifier. Now, for the first time in 150 years, the letter P appeared on a circulating American coin, and it appeared there for a specific, wartime reason: identification for future recovery. Denver received a large D and San Francisco a large S, both placed in the same prominent position above Monticello. The transition was complex. In 1942, both regular nickel composition coins and new silver composition coins were produced simultaneously at different mints. Philadelphia and San Francisco struck war nickels in the new silver alloy. Denver continued producing regular copper-nickel coins through the end of 1942, switching to the silver composition in 1943. By 1943, all three mints had converted entirely to the wartime alloy. Production continued through 1945. Hundreds of millions of silver war nickels entered circulation. The nickel metal that would have gone into those coins was instead sent to the steel mills and alloy foundries that were producing armor plate, engine components, and ordnance for the armed forces. The coins were not beautiful. The wartime alloy did not always blend well, and lamination defects and irregular oxidation were common. The silver content caused them to tarnish differently from regular nickels, developing a dark, uneven patina. They looked worn even when new, but they worked in pockets, in cash registers, and in the vending machines that dispensed cigarettes to a nation at war. The change in American coinage was a meaningful but modest contribution to the nickel supply. The real source of Allied nickel, the overwhelming, dominant, irreplaceable source, was the Sudbury Basin. In 1941, the Allied governments asked Inco to increase production. The company committed $35 million, entirely from its own resources without government subsidies, to expand nickel output by 50 million pounds above 1940 levels. The Canadian government allowed Inco to amortize $25 million in expansion costs over 5 years instead of the normal 10 or 20. The expansion was completed by 1943, an enormous task accomplished without any interruption in ongoing production. The man responsible for this feat was Ralph Parker, the American-born General Superintendent of Inco's Mining and Smelting Division. Parker organized the enlargement of every mining and processing facility in Sudbury simultaneously, sinking new shafts, extending existing tunnels, expanding smelter capacity, increasing refining throughput, while maintaining continuous production throughout. It was one of the most impressive industrial expansions of the war, and it received almost no public attention. Labor was a constant problem. Miners were released from Ontario's gold camps to work in the nickel operations, but housing shortages in Sudbury kept many away. In August 1942, the Canadian government used its War Measures Act powers to allow women to work in surface mining operations for the first time in Ontario history, overturning legislation that had prohibited women in mines since 1890. A second order in September allowed women into the Port Colborne refinery. Over 1,400 women were hired, performing jobs that ranged from operating ore distributors to piloting underground ore trains to working in the machine shop. Elizabeth Lisa Dumencu of Lively, Ontario, near Sudbury, was 21 years old when she answered the call. She and hundreds of other women entered a world that had been exclusively male for half a century, the dark, hot, noisy interior of a nickel mine and smelter. They operated flotation cells that separated nickel from waste rock. They repaired machinery. They drove the small electric locomotives that hauled ore carts through underground tunnels. They did this work not because they had chosen mining as a career, but because the war demanded it, and the men who had done the work before them were fighting in Europe and the Pacific. The scale of Inco's wartime operation is difficult to comprehend without numbers. The Sudbury Basin contained multiple mines, Creighton, Frood Scobie, Garson, Lavac, and others, each one a massive underground operation with shafts extending thousands of feet below the surface. The ore was hoisted to the surface, crushed, and sent to the Copper Cliff smelter, where it was roasted and smelted to produce a nickel-copper matte. The matte was then shipped to the Port Colborne refinery on Lake Erie, where electrolytic refining separated the nickel from the copper and recovered the precious platinum group metals. Every step of this process was expanded during the war. More shafts were sunk, more ore was hoisted, the smelter was enlarged, the refinery added capacity, and all of this was accomplished while the price of nickel was controlled by the government at 31.5 cents per pound, below the wartime inflation rate. Inco was, in effect, subsidizing the Allied war effort through reduced profit margins on its own production. The relationship between Inco and the Allied governments was not always smooth. The company's pre-war contract with IG Farben, the German chemical giant that would later produce the Zyklon B used in the Holocaust, was a source of political embarrassment. Inco had also sold nickel to Japan before the war, but once hostilities began, the company's commitment to the Allied cause was total and unambiguous. All nickel was placed under government allocation. Non-essential civilian uses were banned. Inco monitored the movement of its product meticulously to ensure that not a single pound was diverted to unauthorized use or smuggled to the enemy. The price of nickel was under strict government control. From 1939 to 1941, it sold for 35 cents per pound. For the remainder of the war, the price was reduced to 31.5 cents per pound, less than it had cost during the First World War when it had sold for 40 to 55 cents. Inco's profits fell 25% during the war years despite vastly increased production, a consequence of capital expenditure, war taxes, and the more costly mining methods required to accelerate output. Inco's CEO, Robert C. Stanley, stated in 1939, "The first obligation of every corporation, as of every individual, is to give the utmost support to his government in the prosecution of the war." These were not empty words. The company's facilities in Sudbury, Port Colborne, and Huntington, West Virginia were placed at the complete disposal of the Allied war effort. When Falconbridge Nickel's Norwegian refinery at Christiansand was captured by German invasion forces on April 9, 1940, Inco stepped in and refined all of Falconbridge's matte for the duration of the war. On May 17, 1943, a live Canadian Broadcasting Corporation radio broadcast from Sudbury announced, "The ships, guns, tanks, and planes that today are taking part in a victory which in our hearts makes us proud and grateful have been hardened and toughened by Sudbury nickel." From 1939 to 1945, International Nickel delivered to the Allied countries 1.5 billion pounds of nickel, 1.75 billion pounds of copper, and over 1.8 million ounces of precious platinum group metals. The tonnage of ore mined during the 6 war years equaled the total production of the company and its predecessors during the previous 54 years of their existence. 95% of all Allied nickel came from Sudbury. Inco's contribution was not limited to raw nickel. The company also manufactured the specialty alloys that turned nickel into weapons. The Huntington Works, located in Huntington, West Virginia, was Inco's primary rolling mill and alloy fabrication plant. This facility produced Monel, a nickel-copper alloy with exceptional corrosion resistance, and Inconel, a nickel-chromium alloy capable of maintaining its strength at temperatures where most metals fail. Both alloys were Inco inventions, developed at the Huntington facility's research laboratories. During the war, the Huntington Works produced ordnance equipment, specialty alloys for aircraft engines, corrosion-resistant components for naval vessels, and hundreds of other military products. The plant was awarded the Army-Navy E flag, the highest recognition for wartime production excellence, when the honor was first established, making it one of only 14 facilities in the country to receive the initial award. By the end of the war, it had been honored 6 times. At one of the award presentations, Rear Admiral W.H.P. Blandy, chief of the Naval Ordnance Bureau, told the plant's workers that they are in the Navy on shore duty. It was an accurate description. Without the specialty alloys produced at Huntington, the Navy's ships could not have operated in salt water, its aircraft could not have flown, and its guns could not have fired. The strategic significance of Sudbury is best understood by examining what happened to the nation that did not have it. Germany entered the war with a critical weakness in nickel supply. The country had no domestic nickel deposits of consequence. Its primary pre-war source was Inco itself. The company had signed a long-term supply contract with IG Farben, the German chemical conglomerate, before the war. When hostilities began, that supply was immediately cut off. Germany scrambled for alternatives. Finland's Petsamo nickel mines, near the Arctic border with the Soviet Union, were a critical objective. Germany maintained a military presence in northern Finland, partly to protect access to those mines. Norwegian nickel refining capacity at Kristiansand was captured when Germany invaded Norway on April 9, 1940. Small deposits in the Balkans were exploited. Greece's limited nickel resources were seized after the German conquest in 1941. But none of these sources, individually or combined, could approach the scale of Sudbury. The mathematics were stark. Inco alone delivered 1.5 billion pounds of nickel to the Allies during the war. Germany's total nickel consumption from all sources over the same period was a fraction of that number. Every German weapons designer worked within constraints that their Allied counterparts did not face. Every alloy specification had to be adjusted for the materials actually available. Substitutes were employed wherever possible. Manganese for nickel in some steel grades, molybdenum where heat resistance was the primary concern, but these substitutions always came with trade-offs in performance, durability, or reliability. The consequence was metallurgical. As the war progressed and Germany's nickel reserves were consumed, the quality of German steel degraded. Armor plate that had contained optimized percentages of nickel, chromium, and molybdenum in 1941 was being produced with reduced alloy content by 1944. Tank armor became brittle. Engine components failed sooner. Gun barrels wore faster. This degradation was invisible to anyone who was not a metallurgist. A Tiger tank rolling off the production line in 1944 looked the same as one built in 1942, but the steel was different. The nickel was gone, or reduced to trace amounts, and the performance of every component suffered accordingly. German engineers compensated with clever design, with heat treatment, with substitution of other alloys where possible. But there is no true substitute for nickel in armor plate or superalloys, just as there is no substitute for chromium in stainless steel. You can reduce the content, you cannot eliminate it without consequences. The Allies, drawing on Sudbury's seemingly inexhaustible supply, maintained consistent alloy quality throughout the war. An American Sherman tank built in 1945 contained the same percentage of nickel in its armor as one built in 1942. The P-51 Mustang's Rolls-Royce Merlin engine, license-built by Packard in Detroit, used the same nickel alloy exhaust valves from the first production run to the last. Consistency is invisible. It is also decisive. The 5-cent coin was not the only American denomination modified during the war. In 1943, the Lincoln cent, normally struck in 95% copper and 5% tin and zinc, was changed to zinc-coated steel. Copper, like nickel, was a strategic metal needed for ammunition casings and electrical components. The steel pennies of 1943 are among the most recognizable American coins, pale gray, lightweight, easily mistaken for a dime, and prone to rusting. The steel penny was produced for only 1 year. In 1944 and 1945, the mint used recycled brass cartridge cases from ammunition production to strike pennies, giving them a slightly different color than pre-war cents. The nickel, by contrast, was struck in the silver-manganese copper alloy for 3 full years, from late 1942 through 1945. The nickel was not even the only denomination to lose its namesake metal. The entire concept of what belonged in a coin was being questioned. In February 1942, the government had begun paying premium prices for copper, lead, and zinc to incentivize extraction. Later that year, the government redesigned both the penny and the nickel to free up copper and nickel for munitions. The 1943 steel cent and the 1942 to 1945 silver war nickel are the two most visible results of this policy, but the underlying principle extended far beyond coinage. The War Production Board imposed strict allocation controls on virtually every strategic metal. Nickel was one of the first to be rationed. Non-essential uses, chrome plating on automobiles, nickel plating on household fixtures, nickel alloys in decorative applications were banned outright. Every pound of nickel had to be accounted for and directed to its highest priority military use. The vending machines that accepted the new silver nickels were, in a sense, the last civilian application of nickel that the government was willing to accommodate. And even there, the accommodation was to remove the nickel from the coin entirely. Together, these changes tell a story of a nation that examined every aspect of its material consumption and redirected every available ounce of strategic metal to the war effort. The government redesigned the nickel. It redesigned the penny. It rationed gasoline, rubber, and meat. It collected scrap metal from every household in America. It took the chrome off automobile bumpers, the nylon off women's legs, and the nickel out of the coins in children's piggy banks. None of these individual actions won the war. All of them together created a material foundation that made victory possible. The wartime nickel alloy was discontinued in 1945. Beginning in 1946, the Jefferson nickel returned to its standard composition of 75% copper and 25% nickel. The silver war nickels remained in circulation for years, decades in fact, slowly being pulled out by collectors and silver hoarders who recognized the precious metal content. The strategic importance of Sudbury did not end with the war. If anything, the Cold War intensified it. In the 1950s and 1960s, the nuclear arms race and the development of jet aircraft created demand for nickel superalloys that dwarfed wartime consumption. Inconel and its descendants were essential for the turbine blades of jet engines, both military and commercial. The stainless steel industry expanded enormously, driven by consumer demand for corrosion-resistant appliances, automobiles, and architectural components. Inco remained the dominant supplier. Soviet analysts understood Sudbury's significance. During the Cold War, it was an open secret, discussed half-seriously by Inco workers themselves, that the Sudbury Basin was almost certainly on the Soviet nuclear targeting list. If a war between NATO and the Warsaw Pact ever went nuclear, Sudbury would be among the first targets destroyed, precisely because its nickel was irreplaceable to Western weapons production. The workers who discussed this over graveyard shifts at the smelters laughed nervously, but the underlying logic was sound. Destroy Sudbury, and you cripple the Western arsenal. The monopoly eventually faded. New deposits were developed in New Caledonia, Indonesia, the Philippines, Cuba, Guatemala, and the Dominican Republic. Fidel Castro's nationalization of American-owned nickel mines during the Cuban Revolution of 1959 was, in part, a strategic calculation about the value of nickel to the American military-industrial complex. By the 1970s, Sudbury's share of world production had declined from 90% to roughly 30%, and it continued to fall. Today, Sudbury produces approximately 15% of global nickel output. Still significant, still one of the top 10 mining districts in the world, but no longer the irreplaceable monopoly it held during the war years. Inco itself was acquired by the Brazilian mining giant Vale in 2006 for approximately $17 billion. The Huntington Works produced specialty alloys for decades after the war, eventually being sold in the late 1990s. The name International Nickel Company of Canada, the name that had appeared on contracts that supplied 95% of Allied nickel during the most destructive war in human history, ceased to exist. Today, a 1943 war nickel in average circulated condition is worth $1 to $2. Its silver content alone, at current prices, is worth more than its face value. Collectors prize them not for their beauty, they are, by numismatic standards, rather plain, but for what they represent, a moment when the United States government decided that the metal in a 5-cent coin was more valuable as a weapon of war than as a medium of exchange. Here is what the war nickel teaches. It teaches that wars are won in the margins, not by a single decisive weapon, but by the accumulation of thousands of small decisions, each one freeing a few more tons of strategic material, each one redirecting a few more ounces of metal from civilian comfort to military necessity. The nickel removed from American coinage between 1942 and 1945 did not, by itself, armor a single tank. it was a fraction of the total nickel consumed by the war effort. The real supply came from Sudbury, 1.5 billion pounds of nickel mined from shafts sunk a mile deep into ancient rock, refined in smelters and furnaces that ran around the clock, shipped by rail and ship to the steel mills and alloy foundries of the Allied nations. But the decision to change the coin was important for what it represented. It represented a government willing to examine every assumption, question every convention, and modify every practice, down to the composition of the coins in people's pockets in pursuit of victory. It represented a society that understood, or at least accepted, that the war demanded everything. Not just soldiers, not just ships and tanks and aircraft, but the metal itself. The atoms of nickel that had, until 1942, circulated invisibly through the economy in the form of 5-cent coins. Those atoms were needed elsewhere. They were needed in the armor plate of a tank rolling toward the Siegfried Line, in the exhaust valves of a Corsair launching from a carrier in the Philippine Sea, in the turbine blades of a destroyer chasing a U-boat in the North Atlantic, in the Bailey Bridge that an engineering battalion threw across the Rhine in the spring of 1945. The coin was a symbol. The metal was real. And if you hold a war nickel in your hand today, if you feel its weight, read the date, see the oversized P above Monticello, you are holding a piece of the war. Not a replica, not a souvenir, a piece of the actual material decision that a nation made when it decided that winning mattered more than convention, more than convenience, more than the composition of the coins in its own currency. 95% of Allied nickel came from one crater in Canada. The other 5% came from everywhere else, including the pockets of every American who spent a nickel between 1942 and 1945. Every one of those coins, once spent, once deposited in a bank, once returned to the mint, entered a system designed to recover and redirect every atom of strategic metal. The war nickel is one of the few artifacts of the Second World War that ordinary people can still hold in their hands. You do not need to visit a museum. You do not need special permission. A war nickel can be purchased from a coin dealer for a few dollars or found in a jar of old coins in a grandparent's attic. It is small, tarnished, slightly discolored from the imperfect wartime alloy. It weighs 5 grams, the same as a regular nickel, because the mint calibrated the new alloy to match. It has the same diameter, the same edge, the same portrait of Thomas Jefferson. Only the oversized mint mark betrays its secret. Inside that coin is 35% silver, a metal that the government considered less valuable than nickel. Think about that. Silver, the metal of jewelry, of tableware, of currency since the dawn of civilization, was considered expendable. Nickel, the invisible alloying element that most people had never heard of, was not. The hierarchy of value was inverted by war. Silver went into pockets. Nickel went into armor. The silver came back to the coins. The nickel went to the furnaces. And the furnaces made the metal that made the weapons that ended the war. The arithmetic of nickel in the Second World War deserves a final accounting. From 1939 to 1945, international nickel delivered to the Allied nations 1.5 billion pounds of nickel, also 1.75 billion pounds of copper, and over 1.8 million troy ounces of platinum group metals, palladium, platinum, rhodium, all extracted from the same Sudbury ore bodies. The tonnage of ore mined during 6 years of war equaled the total production of the company and all its predecessors during the previous 54 years. Half a century of mining, compressed into 6 years. The United States produced approximately 300,000 military aircraft during the war. Each one contained nickel in engine valves, in exhaust systems, in structural alloys, in instrumentation, in landing gear. The B-29 Superfortress alone consumed thousands of pounds of nickel alloys per aircraft, and 3,970 B-29s were built. The United States produced approximately 88,000 tanks during the war. Each one was clad in nickel-steel armor plate. The United States produced approximately 350 destroyers, 120 escort carriers, 27 fleet carriers, and hundreds of submarines. Every one operated in saltwater. Every one required nickel alloys in its propulsion system, its heat exchangers, its condensers, its weapons systems. The United States produced approximately 12.5 million rifles, 2.6 million machine guns, 41 billion rounds of ammunition. The gun barrels, the breech mechanisms, the recoil systems, nickel steel throughout. And somewhere in that vast accounting, somewhere in the billions of pounds of strategic metal consumed by the arsenal of democracy, there are the nickels. The small, silver-colored coins that Americans carried in their pockets from 1942 to 1945, thinking of them as money, not knowing that the missing nickel was already in a furnace, already in a billet of alloy steel, already on its way to becoming part of a weapon. The coin was 5 cents. The metal was priceless. That is the story of the nickel that contained no nickel. It is small. It fits in your hand, and it carried the weight of an entire nation's determination to win.